You've got a geometric series if you're multiplying again and again by some common ratio, like the series 2, 4, 8, 16. This is a geometric sequence because we're multiplying every term by 2. And if we needed to add all of them up, we have the sum of a geometric series, which is what we have over here. So basically what they've done for us is they summarize the information about geometric sequence and the geometric series. That if you have a geometric series, the sum can be computed pretty quickly if you know what x is. It's just 1 over 1 minus x. So we can use that to create a power series for this function over here. We can rewrite this function and we can expand it into several different terms that are being added together so that it's equivalent, as we go towards infinity. So we want to be centered at 8, which means that when you expand our power series, there's an x minus 8 term that's multiplying to everything. Something here plus something else here times an x minus 8 to the second power. That way, if you were to plug in a equals 8, all those terms are going to cancel out. So that's what they mean by centering at x equals 8. At a equals 8. So in our sum, the sum of our power series, we want 1 over 1 minus x minus 8. It's like instead of saying it's centered, this is centered at x equals 0. This is a power series centered at x equals 0 because this is x plus 0 to the nth power. So instead of having a sum centered at x equals 0, we're trying to make a sum that's centered at x equals 8. So I'm going to replace this with x minus 8. And so if you expand that, it actually matches what we're working with, right? Minus a negative 8, that means we got 9 minus x. Same thing. But in other words, what that means is that our power series just needs to be the sum of n equals 0 to infinity of x minus 8 to the nth power. Okay, so this one, there's not a lot of math that we have to do. It needs to be centered at x equals 8, which means we need to have an x minus 8 term throughout our power series expansion. So that means instead of being centered at x equals 0, like the formula that we have for power series is given up here, we need this to be x minus 8. And so that means this x needs to be x minus 8. So this is the power series expansion. The interval of convergence, if you wanted to apply the ratio test to figure that out, that would be the next term divided by the current term. It's the absolute value of this needs to be less than 1 according to the ratio test, right? Because this is like our R. Actually, I think their textbook might use L, whatever letter you want to call it. This ratio needs to be less than 1 to converge. And so if you simplify, it's just the absolute value of x minus 8 needs to be less than 1. So that means negative 1 is less than x minus 8, which is less than 1. If you want to solve the absolute value inequality like that, you can break it up into 2 separate absolute value inequalities, but we're going to get 7 is less than x, which is less than 9. So we have a radius of convergence of 1, because there's one distance from one endpoint to the center, and then that would be the interval of convergence. So an interval notation that's 7, 9.